Alright, another area problem. So we've got an athletic field. It's going to be built in the shape of a rectangle, x units long. So they're calling that top right there x, capped by semicircular regions of radius r. So that diameter there is 2r. But if you're only thinking about half of it is just r. What is the area of the maximum rectangle? Because we know that overall there is 400 meters for the racetrack. So we need to remember what the formula for the circumference of a circle is, because that's going to be part of our racetrack. Because if you think about it, our racetrack is going to be x, and then plus the circumference, because half of it is going to be there, and then half of it is going to be over there. So circumference equals pi times the diameter. Well, the diameter is 2r, so circumference equals 2 pi r, which, we also already knew. But, anyways, c equals 2 pi r, and we know that 2x plus c equals, what was it, 400. So I'm going to continue that. 2x plus 2 pi r equals 400. And now we want to find the maximum rectangle, so we need to write the area equation of the rectangle. So a of x is going to equal, the area is going to be x times 2r, because 2r is the other side of that rectangle. So now let's go ahead and solve this we can actually go ahead and solve for 2r. So if we do that, we're going to get, let's go 2 pi r equals 400 minus 2x, and then we can divide by pi on both sides to get 2r equals 400 minus 2x over pi. And I can substitute that in for 2r in my area equation. So area of x equals x times 400 minus 2x. And I'm going to write that pi right there. And then one last simplification. I'm going to pull the 2 out. So I'm going to get 2x over pi, which you can just write as 2 pi times x if you choose, times 200 minus x. And again, now I know that my window is going to go from 0 up to 200, because that's going to be my 0. So let's go ahead and plug in this equation and do a zoom fit. And again, it gives me a near perfect graph, and it gives me a minimum value of 0, because I know I have a 0 there, and a maximum value of about 100. Oh, that's totally a lie. I wonder if I messed that up in the other problems. Let me know if I did. The y max should be 6,367-ish, somewhere up there, because it tells me that my maximum x value is 100. It tells me my maximum y value, which is actually my area, is 6,366.198. So the question is, what are the dimensions x and r to the nearest meter? So x is 100, and now we need to find r. So let's substitute that x value of 100 into our equation. And we're going to get, let's go 400 minus 2 times 100 all over 2 pi, which is going to simplify to 200 minus 100 over pi, if you see what I did there, which is 100 over pi. But we want to round that, and so we're going to round it as a r value of 304, and what does it say, the nearest meter? So 314, which is a lovely number.